Hey guys, welcome back. So this is our part two of complete DBMS for placement and interview. In day one, we start from the basic. Okay, we read about the DBMS, file store technique, and relationship, then keys, like that, na? And schema also. In part two, we are going to learn about the ER model, EER model, codes rule, and data structure. These are the four topics we are going to cover in this lecture. Okay, so start with the first one, ER model. First, we understand about the ER model. ER model. Here, ER stand for E stand for entity, and R stand for relationship. In previous video, we talk about both the things. Relationship. Okay, entity means we call entity for the table. Table, we like if I have a table, we can say it's a entity table. Relationship means relation between the two table. Okay, two or more tables. Like we understand relationship means relation, or we can say connection between two or more tables or entity. We can say anything. Okay, we know about the ER entity and relationship model. Its full meaning is entity relationship model. So it's used for, we can say, yeah, it's also known as framework conceptual. Okay, it's known as conceptual for framework. Okay, conceptual framework. Okay, we can say it's known as conceptual framework. Used to it's used to describe and design the structure of database. The structure of database. That means while we use ER model, it's used for describe the structure of database. That means when we have to design the database, now we need the ER model. Okay, ER model. So first, understand about the ER model. We need to know about the ER diagram. Okay, we have to know about the ER diagram. Then we explain the ER model again. First thing, it's a conceptual framework and describe and design the structure of database. Okay. After that, we have to know about the ER diagram, entity relationship diagram. Diagram means it's a graphical representation. So, graphical representation of a structure of the database. We can say the graphical graphical representation of relationship of the table. Understand? What is ER diagram? Graphical representation of relationship of the table. Okay. Next we can say, uh, yeah. Now talk about the relationship. We read in previous lecture. Relationship has three types, like one to many, many to many. Okay. If we see relationship, there is one to many, and many to many. These are three things, na? Okay. Now, now we have to talk about like what we learn? EI diagram. For the creating diagram, we need some symbol like that. Na? Okay. Now we talk about the graphical symbol. Graphical symbol. Okay, like if you have to describe the entity, this is the entity here. Okay. Second, what we need? Again, we need some attributes. These are the attributes. Okay. Next, we have to define the relationship. In diamond sim, it's a relationship. Okay. After that, we can say in attributes, we have primary attributes, composite attribute like that. So we can say this is a primary attributes here. We can say it's a primary key. Okay. Again, one more thing. Cell over under circle like that. It's a it's so multiple. Oh, sorry, multi-valued attributes. Okay. And one more thing we have like entity, primary attributes, multiple attributes, sorry, primary key, multi-valued attributes, and one more composite. I define here. Means I write here. These are the composite, composite attributes. Okay, these are the attributes. This is relation entity, and we have a weak entity. Okay, this is a weak entity. Weak entity. Okay, after that, what we need again? Entity, weak entity, attributes, primary key, multi-value, relationship, composite, and that's it. From with the help of this symbol, we create ER model, ER diagram. Okay, so there is some rule to create to make the diagram. We can say rules for the creating ER model. Okay, with the help of sub symbol like diagram. Okay, na? So write some rules. So first is we have to identify the active elements. Okay, identify the active element. Identify the active element of organization. For what you just create ER model. No? Second, we know the active element. Then we have to know about the relationship. Identify identify all the relationship among entities. Okay, entities means relationship between all tables. Third, we have elements. Then we have relation, and now we have to find the key attributes. Find key attributes. Key attributes of entity. Okay. After that, we have to like we have key attributes. No? After that, we have to find the other attributes. Then find other attributes of entity. Okay, that's it. Now we can complete the diagram. Complete. Yeah. Okay, yeah, diagram. After that, that's it. Last we can say check it. These are the six steps. First, we have to just identify the active element, then relationship, then key attributes, and other attributes. We can say all of the attributes. And next, we have to write. Okay. So take an example and construct it. Okay. Now we are going to draw. Yeah. Here we can say you have to make a ER diagram for. We can see. Take an example of university. Construct Construct ER diagram of university. University. Okay. So what we have? Rule number one. Identify the active element. Rule one. Identify the active element of entity. Okay. Let me check once if everything is going to be okay. Yeah, voice is okay. Video is also okay. Yeah, done. Then we have to talk about the identify the active element of entity. Now, so in university, what is the active element? What will be? In university, we have some students, some courses, teachers, some department like that. Na? So right here something like students first, teacher. There is some courses and there is some department also. Okay, let four active element of the entities. Okay, after that we have second thing. Now we have to make the relationship. Okay, means identify the relationship. Identify the relationship among entities. Okay, now we have like we have department. We can say we have department. Though so we can say department. This is the symbol of relationship. Here we learn now. This is relationship. Okay. So department has relationship. Wait, we can say has here. Relationship has relationship with whom? If we have department, so department has some teachers. Teachers. This is the symbol of relationship. This is the symbol of entity. Okay. So department one has many teachers. This relationship is one to many. Okay. Next we have department. Department has teachers and what we can say. Yeah, we can say one more thing. Department has many teachers, but department has only one head, like HOD. Department has relationship only one teacher. Okay, so it is the relationship of one to one. Next, we can say department has okay, like one department offers, we can say it's offer many courses. Yeah, in one department there is many courses. We can say one to many. This is the courses. Okay. After that, these courses, these courses is by some courses like one courses or we can say there is many courses. Na? There is many courses. So many courses. Uh, we can say enroll by enrolled by many students. Many students. These are the relation. And we can show sorry, we can say one more thing. Courses teach by anything, anyone, na? Teach by one courses, or we can say many courses teach by one teacher or many teacher, anything we can say teacher. So we find some relation between them. Okay, you can add one more thing. no issue. Okay. But right now we do this. Department head, teacher. Department head, one head teacher as head by. You can say head by. And department offer many courses enrolled by many students. Courses like many courses teach by one teacher. We can say next. What we have to do? We done this. Now we have to find the attributes, key attributes first. Third, third case means third step. Find key attributes. Okay, like key attributes is like for department, for teacher, for courses, for students. Okay, for department there is key attributes like primary key is department ID. There is some ID. We will see the oh sorry. Okay, TID. Teacher for some TID. We can say courses for some CID. Okay, C1 courses ID, teacher ID, department ID, S stand for SID, or we can say roll number like that. Okay, now we have attributes DID, TID, CID, SID. Okay, means ID for the particular one, particular one. Now next step, fourth. Now we have to find the other attributes. Other attributes. Okay, now what we have to like other attributes as like we have ID, some name. Okay, teacher has some salary, department has courses, like courses has some subjects like that. So in department we will see for all of four na one, two, three, and one more. Wait. Yeah, one more thing here. Okay, this is for the teacher. Okay, first we make for the students, then teacher, then department, then courses. We have four tables. Like what you have to in student, there is some SID we mention. Then we have some student name. There is some student we can say class. Okay, we can say student has some address. Student has some we can say phone number. Student has like it. That's it. Enough. Now we have teacher. For teacher, teacher ID, teacher name, teacher salary, teacher address, teacher phone number. That's it. Next, for department. Department says some department name, some department like we can say address or contact like some department has email. Courses. See, there is a courses name. Then courses we can say some fee, courses duration like that. Okay. Here we have four tables. Student, teacher, department, courses. Okay, done. And table has some attributes. Okay, done. Next five. We have to draw this. We have to draw this. Now our main work is here. So what we have? We have four tables. One, So we can make like uh, 3 and 4. We have four tables. Okay. One for department. Second for teacher and courses and students. Okay. Now we have key attributes for one. For these key attributes, that means primary key is DID. For courses, there is CID. For student, there is SID. For teacher, there will be TID. Sorry, we have to make the relationship, na? Yeah, department has what we write there. Department has many teacher. Department and teacher. Department has teacher. Like okay, we can say here department has teacher. Okay, first thing, department has teacher. After that, department head by teacher also. Department head by teacher. One more relation. One more relation here. Sorry. Done. Uh, this and yeah, this. Okay, head by here, head by. Okay, one department head by one, and many department. Sorry, one department has many teacher. This is the relationship between them. Then department has courses. Department offer courses, na? Department offer courses. This is the relationship between them. Okay, now we can write here offer. Department offer many courses. One department offer many courses. Okay, next what we have courses enrolled by students. Courses enrolled by students. Courses enrolled by we can say here enrolled by one. Courses enrolled by many students. Okay, this is the relationship and courses teach by teacher. Okay, courses teach by teacher. Courses teach by teacher na. Okay, here we can say make here courses teach by. We can say one course or many course teach by teacher. Okay, or one course teach by one teacher. Okay, these are the relationships we created. Okay, now we can say, wait, huh? We just move this one here. Wait, go clearly. Here we can say this one courses teach by teacher. Okay, okay. Now we have to create what we done, identify, then relationship with made key attributes, and we have to mention other attributes also for other attributes. Department is right there. Department has some D name. Department has also the contact, some email, Okay. After that, for teacher, teacher has some T name, and we can say the address here, T or TID. This is the primary key. Okay. The contact number like that. The salary, and for the students, we have for student we have like student name, student phone number, student address like that. In courses, there is some course name, there is some course fee, there will be some course duration. Okay. These are our ER diagram. Okay. This is our ER diagram. Okay. Understand? After that, we can say this is our ER diagram. Okay. This is graphical representation of relationship between tables or entities, we can say. A model is we created diagram. Okay. Now we talk about a model. Model is a conceptual framework. We can say it's also known as a conceptual framework used to describe and design the structure of the database. These are the structure of the database. Okay. Okay. Now we created the ER model. Okay. After that we can say now we have next move topic. Move on to this ER model done. Now we have EER model. Okay. Now we have EER model. Okay. Now we have ER model. Like ER model stands for enhanced. It's enhanced, or we can say, or extension, extension, extension of entity relationship. That model, entity relationship means it's a extension of that model. Na ER model का extension EER model. Okay, this is the extension of ER model. That means there is some issue like here. If you look at this there is some like jibbling, na. So for this not happen. Okay, we use the EER model now. This is the advanced version. This is the advanced version of ER model. We can say, we can say, yeah, enhanced entity relationship model. Like we can say, mm, in ER model, we can say here, this ER model makes, we can show complete real world relationship. Okay, complete, complete real world relationship more easy. Do it all. Do it all. Its additional features. Its additional concept of features like because it's a advanced version, so it's a some more features na like we have generalization, generalization, then specialization and aggregation and union, subclass and superclass. What is the features? Generalization, specialization, aggregation, union, superclass, subclass. Okay. So with the help of this, we make the ER diagram more easy. More easy. Okay. Just it's a high level data model. Na? It will be it's a high level data model. We can say high level because it's an extension high level data model. Okay. There is some features. If you talk about the features of this model of EER model. Okay. Write it here. First, EER model create the design the more accurate. Okay. It design the model or a structure. It will be the more accurate. We can say more accurate. Sorry, design more accurate schema or a structure. Okay. Second thing, design more accurate structure. First thing. Second thing, we can say all the feature of ER model. It's include. It include. It includes all the modeling feature. Modeling feature of ER model. Okay. Third. Third, we can say it's used for the design the complex database. Okay, it's used to design complex database. Okay, or we can say yeah, that's it. It's used to use sorry, it's used to design more complex database. Okay, if we have normal database, we can use ER model and create it. But for the complex or in large industry, we have to create na. Then we use the EER model. Like we can just continue that example, like for the university. Okay, again we have make the model for the university again university. So in university, there is like mm, we have some entities like teacher and students, two things. So we can say teacher and for teacher, student and staff. Okay, for that we can say there is a person. Okay, take a person. It's a general integer. General entities. Okay. Second thing. Second thing. In person, it could be student and it could be a teacher. So both are the both are specialization. Specialization. General specialization. Two things. And and now we have also the aggregation sum. We have to do some aggregation also. Okay. So third thing like mm, department is the department aggregate. You get the teacher and courses. Okay, relationship between them na teacher teach the courses. Department some department is teacher and courses also. Okay, so department aggregate teacher and the courses. We can say so. Make here create here draw ER model. So there is a department first thing. Okay, second thing we have there is some teacher. There will be some courses and there will be some students. Wait. Yeah. Hmm. Okay, I will create again. I'm going to draw here. No? I'm going to draw here. Okay. There is some department first. Okay. Department has some teachers. Okay. Department has some teachers. Okay. And department head by some teacher. Head by teacher. Two things. Now, teacher has some courses. Now we can say teacher has some courses. Teacher, like now we can say teacher mm, has or teach courses. And next, courses is enroll by wait. Courses enroll by courses enroll by some students. Okay. So courses enroll by we can say a person. It could be a person. Sorry, it could be a teacher or no. Person is a only enrolled by students, na. So students can be we can say is many things like student from the from any department. It aggregate na student from the BCA department, BCA from the BTech like that. So this is our schema, not schema EER model. Okay. Now we can say we can create like that relationship like na. Just create here and map to this. These are the relationship between. These are the EER model. Okay. I will give you the notes. I will provide. Okay. These are the EER model. Now look at this. Both the model. Sorry, diagram. These are made complex like look in looking wise. This is the complex. This is more easy. Okay. Now we're done with the second one also. Now we have to learn about. Now we have to learn about what you have to do next. Next is one. ER model done. Codes rule. Now we have codes rule. There is 12 rule. Okay. Now you have to read about the codes rule. Okay, there is 12 rule. Like we can say there is completely 13 rule. Like code rule 0 is also there. So we are starting the we are going to write yeah first zero rule. Okay. In zero rule, what it say? In zero rule, all the system must support relationship database. Okay, all the system what you have and other end must support the database system. So relationship database feature. Okay, all the system, basic rule is all the system must support relationship relationship database feature. Okay, understand? All the system must support relationship database concept features. Sorry. It also named a zeroth rule. We can say it's a system rule. This is talk about the system now. It is a system rule. Okay, first thing done. Now we have second. That is the first rule. First rule. First rule is mm, we can say if it's a relationship database, na, so all the database data is stored in the table format. Okay, all the data must be stored in tabular format. Tabular format. Okay, we can say this is first rule must be shared in the tabular format. We can say uh, information table. Yeah, I don't know. Maybe you can check once. Information table. Okay. Now we have uh, second rule also. Second, right, like that. Okay. In second rule, first for the system, all system like all system has the feature of relationship database. Okay. And first rule, information table. That is say all the data must be stored in the tabular format. Now next. Now we talk about the inside the table. Okay. Second rule, a table must contain a column which can pick a record uniquely. We know that that means we have to a primary key na to uniquely identify. So we can say here second rule is guarantee access rule. Guaranteed access rule. Okay, there is a unique value. That is primary key. Now third rule. Third rule. Now we have third rule is the system. The system must handle null values. Okay. The system must handle the null value. Okay. It's known as like we can say uh, null handling. Null handling. Okay. Now we have fourth rule. Fourth rule. In fourth rule, we can say database schema. Database schema must be stored in stored as relational model. Relational model, or we can say table. Okay, database schema must be stored in relational model. We can say we known as uh, dynamic catalog. Dynamic catalog, or we can say description database. Descriptive database. Okay. Now we have fifth rule. We have the fifth rule. Fifth rule. Okay. We understand about the zeroth rule. That is, system must uh, support the relational based database. Okay, relational database. Second is for the all the data stored na, in tabular format. Second thing. Third, we have right zeros for the system rule stored in the tabular format. Then guarantee access rule. There is the primary key and null handling support the null. And then fourth, a dynamic catalog or descriptive data. Dynamic schema stored as a table. Fifth rule. Now we have fifth rule. Database support database support all the sub-language like DDL, DML, DQL, okay, DCL and TCL. This is the sub-language of SQL. Okay, we'll learn SQL later. In this series, we will do database support all the sub-language. Okay, fifth rule. Now we have sixth rule. Sixth rule. Sixth rule is, oh sorry, we known as, one more thing we have to write here. We known as comprehensive, comprehensive. We can say data sub-language. Sub-language. Okay, now sixth rule. Sixth rule is all the view that are theoretically, all the view data theoretically updated must be must be updated by system. Must be updated by system. Okay, now all the view data theoretically updated must be updated by the system also. So this is, we can say, updation rule. Updatability. Updatability rule. Okay. Next, we have seventh rule. Seventh rule. Here we can say in seventh rule, uh, now we have database must support. We have to talk about the database must support SQL. Okay. Insert, update, and delete operation. Okay. We can say this is the set operation rule. Okay. Set operation rule. Okay. After that, we have eight rule. Eight rule. This is if physical data change should be should not affect how data is accessed. Okay, physical data then should not affect how is accessed. Okay, now if it's enough, it's we can say physical independence. Physical data independence. Okay, now ninth rule. Ninth rule. We have ninth rule as if you change the logical structure, changes to the logical structure should not should affect data access. Okay. One is logical data independence. Logical data independence. Here, difference. Now, look the difference. Physical data independence, it's a logical data independence. Means physical change should not affect how data is accessed. Change in the logical structure should not affect the data access. That means if you change the in physical data or logical data, it should not affect the actual. Okay, how data is accessed. Now, ninth rule. Ninth rule. Now, ninth rule is like changes to the logical structure. Logical structure should not be. Change the logical structure. We have done now. This rule is done. Logical structure. Yeah, it's done. Now, oh sorry, ninth rule is done. We have to write the tenth rule. Tenth rule. Okay, now we have tenth rule is integrity and integrity constraint should be should be defined. Integrity constraint should be defined in schema. Defined in the schema. Okay, we can say this is the integrity rule. Integrity dependency. Okay, now we have 11th rule. Now we have the 11th rule now. 11th rule. 11th rule, as we can say here, 11th is distribution of data. Distribution. What is distribution of data? Okay, across location should be invisible to user. Invisible users. We can show a distributor. Distributed. Sorry, distribution dependency. Dependency. Okay. Now we have 12th rule. Last one. 12th rule. Now we have 12th rule. Last rule as like number of number name. Notice the 12th rule was like first we see what we done. We have done as a zeroth rule. Zeroth is known for the system rule. That is the all systems support the relationship database feature. Okay, all the system support the database feature. Also, sorry, relationship database feature. Second, all the data must be stored in the table format. Okay. Second, now we have the sorry, first rule. Now we have the second rule, guarantee access. That means all have the primary key. Third rule, null handling. It should handle the null value. Fourth, dynamic catalog or descriptive database. Database schema must be stored in the relation mode like tabular format. Comprehensive data sublanguage. That means database support all the sublanguage like DML, DQL, DCL, okay, DDL or TCL. These are the five. Okay, next updatability rule. All the view are that are theoretically update must be updated by the system. Okay, it's the updatability rule. Next, seven rule set operation rule means it support the SQL all operation insert, delete, update. And eighth rule physical data independence. See, and logical data independency 9. 8 and 9 say if you change the physically or logically data, na, then it should not affect the how data is accessed. Okay. Now 10th rule integrated dependence. Integrity constraint should be defined in the schema. Okay, integrity constraint should be defined in the schema, not in the code or not in the application code. Okay, we can say now we have the distribution dependency code. Distribution of data across locations should be invisible to user. Now we have last will be last left is the no bypassing. No bypassing integrity integrity role low level access. Low level access. Okay, no. bypassing integrity rule. Okay, integrity rule by the low level access. What we have to integrity rule? That's one, 10th one. Okay, integrity rule done. System rule, information rule, guarantee access rule, null handling, dynamic catalog, comprehensive data language, sublanguage, sorry, updation rule, safe optimization rule, physical data independency, logical data independency, and integrated dependency, and distribution dependency. Okay. Now last one is the no bypassing integrity rule through low level access. Okay. Next we can say we known as the non subversion rule. These are the rules of codes rule. Okay, these are the 12 or 13 rules of the codes rule. Understand? That's it. We just we can say we can make a note for this. We can make a notes for this. Like we have we have wait. Wait. Very yeah. We go through first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. These are the rules. Okay. Okay, these are the rules. Okay, leave it. Leave this. We can make your own notes. Okay. Short note like how you remember. Okay. Mm, You make your own. Okay. I again explain one more time. Like, yeah, course. We read about the course rule. There is total 13 rule. Like as a zeroth rule. It's say about the system must support the relationship database feature. Like all the system must have the yeah, all the system must have the support relationship database feature. Okay. Second thing, second and where first one. This is the information table. That means all the data must be stored in the tabular format. Then guarantee access. All the data has the one primary key. Not null handling. There means it support the null system or null values, handle the null value. Dynamic catalog, database must be stored in the relational model. Next, comprehensive data sublanguage. It's support SQL sublanguage. Na? We can say sublanguage like DML, DCL, DQL, DDL, TCL, like that. Next, updatability. All the view data theoretically change. Should be changed by the system. Okay. Next, set operation rule. Database must support the SQL, insert, update, and delete operation. Okay. That means it's completely talk about the relational base, relational database. Okay, like it support the SQL sublanguage, store in the tabular format. Okay, and handle the null values. Must support system must support the relational base, relational database feature. Now, all of the about the relational base, relationship database. Okay, that means if your system support the SQL, na, all the function it's included. Now, A10 right was a physical data independency and logical data independency. If you change the physically or logically data, it should not affect the how data is accessed. Next, 10th rule, integrity rule. Integrity concept should be depends on the system. Oh, sorry, defined in the schema. Okay. Integrated dependency, that means integrity constraint. The constraint defined in the schema, not in the application code वगैरह. In 11th rule, distribution dependency rule. Distribution of data across locations should be invisible to user. Okay. And at the last, no bypassing integrity rule. No bypassing in the integrity rule through low level language or low level access. Okay, completed. Now we have the last data abstraction. Data abstraction. Data abstraction that one we learn in we can say in EER model, like specialization aggregation like that. We talk about here. Yeah, here. Data abstraction. Data abstraction. In data abstraction, like we can say data abstraction is used to represent complex relationship that done by EER, complex relationship between entities. It's using EER model. Okay, there is some feature like aggregation and specialization and generalization. Okay, three things. We already implement this. Now we talk about the first one. I start with the generalization. Generalization. Wait. Yeah. Generalization is the process of converting low level entity into the high level entity. We can say process of converting low level entity into to high level entity. Okay. Generalization means process of converting low level into high level. Like we can say, we will take an example. Okay. We will understand by taking an example. Like suppose we have the three entities. Okay. Means three table you have. And like teacher, employee, and one for the student. Teacher, employee, student. Both, uh, all of three are the person, one person. We can say you have three now. Example: teacher, student, and employee or a staff. Employee. Three things. All of the same attribute like name, age, contact, address, like that. Okay. So after that, we can say they are the low level entity. Okay. We have to convert it the high level. So we can say there is a person is a is a we can say person can be three things: teacher, student, and employer. Easy. We already implement this. Okay. This is called like teacher is a person, student is a person, employee is a person. That means it's a uh, bottom to up. Like we can say bottom up approach. Okay. Understand? Now we have next. We have the next one. Next is specialization. Specialization. Just opposite of just opposite of generalization. Specialization means a person is a like teacher, student, or employee. We can say top-down approach. Top-down approach. Okay, that's it. That's it. And now we have one more thing, aggregation. Now we have one more thing, aggregation. Okay. Now we have aggregation also now. We oh sorry. Do I need to explain this thing? Specialization? Like we can say here, there is some like A, B, C. Both three are the we can say each person. Like just opposite of them. Okay, now we have three. Third. Third is aggregation. Aggregation. Aggregation means it's a process. Process when uh, okay here process when relationship sorry relation between two entity. Okay, process when relation between two entity is treated as a single entity. Sorry, that means process of relation between two entity is treated as a single entity. That means it's aggregate all of two. Okay, we can say here like mm, like this is my channel. We can say logic and learn channel. Okay, offer. This is a relation offers many courses. One channel offers many courses. Okay, second. Now we can understand well. This is for the inquiry. You inquiry about that and visitor. Okay, there is many courses. There is many courses. Many student. Okay, visitor can be many. Okay, all of aggregated is the one. This one. Understand? This one. This is aggregate two function. Sorry, two table like courses and like courses, many courses, na? And many visitor comes there. So this is for the this is for this video. Yeah. In 1 hour and 8 minutes, we complete all of the four topics. It gone. Yeah, done. So we done this part and see you in the next video. Okay. In part three, we will see how to learn like normalization, denormalization. We will do now in next video. Okay. So, chalo, bye bye. See you in the next video.